There are many cool places on our planet where you can conduct strange experiments. For example, you could fry pancakes in the Sahara, play a game of basketball on Mount Everest, fly a kite in Antarctica, or drop a steel ball into the Mariana Trench. They say that this task is given to some students, but this seemed really interesting to me, and I decided to conduct my own scientific research. Theoretically speaking, of course. It's not easy to get to the Mariana Trench, and littering it with steel balls is not such a good idea. I wouldn't recommend doing this. So, in order to solve this unusual problem, it's necessary to clarify some conditions. For starters, we'll deal with the trench itself. We study the situation. The Mariana Trench is the deepest ocean trench on Earth, known to mankind anyway. It's easy to find in satellite pictures without the help of Google. This is the Pacific Ocean. Here are the Mariana Islands and a huge crescent moon in the water. See? The Mariana Trench itself has a deepest point called Challenger Deep. 10,994 meters, or 36,069 feet below sea level, plus or minus a little more. This is just unreal depth. For the first time, the crew of the HMS Challenger sailing ship discovered this place in 1875 and even tried to measure the depth. It didn't work out very well. Technology of that time was incapable. After 76 years, another ship arrived here, which was also called the Challenger. With the help of an echo sounder and improvised means, the team managed to determine the depth of the trench. Then, the Challenger Deep got its name, and at the same time earning the status of the deepest place on the planet. As anywhere, the depth here greatly affects pressure. In the Challenger Abyss, it's more than 1,000 times higher than normal pressure at sea level. Here, it's 108.6 megapascals. And where there is serious depth, there's a change in the density of water. Everything is normal on the surface, but then the water becomes 5% denser, and it's quite cold there, from 1 to 4 degrees Celsius. That's about 34 to 39 Fahrenheit. For comparison, the water temperature off the coast of the island of Guam ranges from 27 to 29 degrees Celsius. That's 80 to 84 Fahrenheit. This is a really warm region, but the sun's rays simply can't get through the deep water in the Mariana Trench, so this temperature variation occurs. All of these factors, of course, affect the local inhabitants. Few are ready to live in darkness, cold, and under tremendous pressure. But will temperature and pressure affect a steel ball when they, to be honest, aren't so strong? As for temperature, it doesn't play a role at all. 1 to 4 degrees Celsius or 34 to 39 Fahrenheit is nothing, especially for steel. The role of pressure is much more interesting. Pressure can compress a substance so much that it's torn to pieces. A pillar of water in the Mariana Trench will easily crush a person, literally. Just 1 second is enough. So, no teleportation right to the bottom. But that's only you, not Wolverine from the X-Men. Well, you know, the guy with the skeleton of adamantium. The human body is too weak to resist such tremendous pressure, but metals are a completely different matter. In order for steel to change its shape, it'll take more pressure than 108.6 megapascals, about twice this much if you use very crude calculations. To do this, you'd have to place the ball somewhere deep into the earth because the pressure of the ocean is certainly not enough. Or send it somewhere outside of our planet. However, pressure in the Mariana Trench will still compress the steel ball and reduce its volume. At thousandths of a percent, you wouldn't even notice it visually. Yes, and it's also unlikely that the inhabitants of the Mariana Trench understand such things. Imagine you're a deep-sea fish, and suddenly a steel ball floats past you. It's unlikely that you would even try to figure out how pressure affects it. Most likely, the ball won't interest you at all if it cannot be eaten. By the way, the changes won't be permanent. If you lift the ball to the surface, it will return to its shape since the pressure will drop to normal. But again, no one will notice this except for engineers who decide to take precise measurements. In general, it would be better to figure out the speed. At first, it seemed to me that the steel ball would sink very slowly and smoothly, that it would be slowed down by the water, but it turned out that everything isn't quite so. A steel ball moving through water will quickly reach its terminal speed. That is the speed at which the force of gravitational attraction is balanced by the resistance force of the medium. Well, and other factors as well. In general, I did some calculations, but I won't bore you with formulas. The maximum speed of the ball would be 15 meters or 49 feet per second. This is comparable to the speed of a car driving in the city. Fast enough, especially for marine life that gets caught in the ball's way. But let's assume that this won't happen. No one will suffer and our ball will not slow anything down. Consequently, the steel ball will reach the bottom of the Mariana Trench in about 12 minutes. There, it will crash into the bottom and most likely get stuck in the silt, maybe even creating something like a small funnel. And this would be one of the biggest events in the Mariana Trench in recent years. By the way, what if we replace the steel ball with something more common, say a tennis ball? No, you need something more impressive. For example, a bowling ball. Usually they consist of different types of plastic, sometimes with the addition of rubber, ceramics, and even glass, but usually without metal. Because of this, bowling balls are pretty buoyant. In any case, they can stay on the surface. For the ball to sink in water, its weight must be more than 5.5 kilograms, or more than 12 pounds. Such objects exist, but I propose to go even further. For example, let's sink a 7-kilogram or 15-pound bowling ball in the Mariana Trench. How fast will it sink to the bottom? Given a speed of approximately 1.3 meters or 4.2 feet per second, it'll finally reach the bottom after 2 hours and 20 minutes. You can throw the ball into the water and watch a movie. It'll be just in time for the final credits. A 5-kilogram or 13-pound ball will reach the bottom in 4.5 hours. But if it's made of iron, then 30 minutes is enough. A bowling ball made of lead will hit the bottom in 23 minutes, and a ball of pure gold in just 17 minutes. Why not drop it into the ocean for the sake of science? So now we have a bunch of bowling balls in the Mariana Trench, but what will happen to that first steel ball once it's already at the bottom? For example, in a week, or in a month, or in a year. Well, the ball will be able to lie in the Mariana Trench for a very long time. In the deep, rust simply doesn't form in the usual way. But at the bottom can live bacteria that simply love metals and oxidize them. Such organisms, for example, have been destroying the Titanic for years. It lies at a depth of about 3.8 kilometers or 2.3 miles, which of course is just nonsense compared to the Mariana Trench. But to bacteria in general, no difference. Huge pressure won't affect you if you're very tiny. It's possible that these bacteria will enjoy lunch with our steel ball. In the end, it will completely collapse and mix with water and silt at the bottom. You can't say the same about a plastic bowling ball. Any synthetic material will have to be lifted from the bottom so as not to affect the environment. So if you suddenly decide to repeat my experiment in reality, don't forget to clean up after yourself. If you liked the video, give it a thumbs up. Don't forget to subscribe to the channel if you haven't done so already. click on the bell to receive timely notifications of new, interesting videos that are waiting for you ahead.